Hi everyone, in this video we are going to talk about how we can determine the spontaneity of a reaction. Right, so in the chapter of electrochemistry, right, we often come across this situation where we pour two things together and we want to predict if a redox reaction will occur. So sometimes the reaction will be spontaneous, sometimes it will not, and it really depends on our E cell value. So what we want is our E cell value to be positive, and our E cell value is equal to the E reduction minus E oxidation. Right, of course, in this case, since we are quoting data from the data booklet, this is in standard conditions. Alright, so at the end of the day, we want to ensure that as long as it is positive, it is spontaneous. Alright, and this is when we add two things together. So let's take a look at the first example. We want to know whether this will lead to a reaction. So you will first have to look at these two species and decide what can possibly happen to them. And we know that for copper, alright, from Cu2 plus, it can only be reduced in this example. Alright, it cannot undergo anything else, so it can only be reduced, whereas zinc on the right hand side can only be oxidized. So since both one can be reduced, one can be oxidized, so we want to pretend that this reaction can happen and substitute the values in. So since this is our reduction half, I'll take positive 0.34 minus negative 0.76, and this will give us a value greater than 0. Alright, and because this is possible, this reaction is spontaneous, so we will get our Cu2 plus will get 2 electrons to become Cu, right, and my Zn will become Zn2 plus 2 electrons. Notice the arrows that I'm using right now. Previously I started with reversible arrow where I just copy and pasted the data from my data booklet, but in this case I have to convert the arrow to the correct direction. So this will be my reduction half cell, this will be my oxidation half cell. I combine them together. Alright, my overall will be Cu2 plus Zn to give me Cu plus Zn2 plus. So this is how we can predict if a reaction is spontaneous or not. So let's take a look at the second example, Cu2 plus versus Zn2 plus. So since both of them exist on the left hand side of the equation, right, the only thing that can happen to them is reduction. So since both of these species can only be reduced, there's no way a redox reaction is going to happen, because for a redox reaction to happen, there must be one that's oxidized and one that's reduced so that the electrons will flow. Alright, so let's take a look at our final example over here. So now we have Fe2 plus and Cl minus. Okay, the best way to tackle this question is to first decide what can Fe2 plus do. And Fe2 plus has a way to be oxidized, and it can also be reduced. So it can be oxidized to Fe3 plus. It can also be reduced to Fe. So you can find this information from the data booklet. Just look at the left hand side for Fe2 plus to see how it's reduced. And so this is what we have, is on the left hand side. And if you look at Fe2 plus on the right hand side, you will be able to find this, which will tell you about the oxidation process. Okay, so based on this information, we should be able to carry on with our question by looking at Cl minus. And by looking at Cl minus, we know that the only way that Cl minus can go is oxidation. So if the oxidation half reaction is Cl minus, right, forming Cl2 and 2 electrons, the reduction half must be this. So Fe2 plus can only be reduced and not oxidized, right, for the same reason as what we have discussed in part 2. So assuming this is the case, we want to find the E cell first before we decide if this reaction is spontaneous. And what we'll do is, since this is the reduction half, we'll take 0.44, negative 0.44 minus positive 1.36, and I think it's obvious enough that this value is smaller than 0, therefore Fe2 plus and Cl minus is not spontaneous. Therefore, you will be able to see FeCl2 aqueous existing on its own. Alright, so this is how we can tackle questions that ask us to determine if a reaction is spontaneous or not.